Chapter of today, chapter number 3, is how to create our ER model. We will be learning, inshallah, how to create ER diagram or ER model. That's basically our data modeling. How do we model data? This is the question. So let's begin. How do we create our ER model? In this chapter, we will learn, inshallah, with the help of a lot of examples, inshallah, of entity relationship, of entities, their relationships, and modeling with ER diagram. When we are talking about database applications, that you are going to make a database application, what does this mean? It means you are developing an application which will be using a database on back end. Okay, front end, you will see front screens, and you will see some forms, you will see some reports, and on the back end there will be database. So a database application, there are two main activities in your database application. The first is you create a database. You will be creating a database which is the back end. Yani people do not directly see the database, rather they see front screens. They see the applications. Like in your mobile, you have several applications which access data from the backend. So your database is backend work, and your application design, yani your front screen of your mobile application or your website or your desktop applications, you have front ends. On the backends, they are using data, and data is stored into database. So there are two major activities. One is database design, and one is application design. In database design, what do? You do conceptual design, then you do logical design, then you do physical design. Okay, we know that. In application design, basically you are designing your application which covers your activities, main activities in your software engineering. I hope you already have taken the course of software engineering before. If not, you will take it, inshallah, no worries. So that is, your application design is related to your software engineering, and this is not part of our course. Our course is related to our database design, where we will see conceptual design, logical design, and physical design. This chapter number 3, it focuses on your conceptual design process. So let's see. Once again, in this picture, you see two major streams. The first stream, which is in the green rectangle, dotted rectangle, the right-hand side, and the blue rectangle on the left-hand side. The right rectangle, it shows your database design process, and the right-hand side, it shows your application design process. Okay, in database design process, first of all, you study the mini world, yani the organization, yani the processes that you want to model. Like we had an example of university. Similarly, you can have other examples of some other companies. You study the relevant part of the company for which you are going to make your database. That is called your mini world. The first step in the mini world is your requirement collection and analysis. Once you get your requirements, we go to our first phase, which is conceptual design. Then you go to second phase, which is logical design. Then you go to third phase, which is physical design. And besides that, if you are designing your application, your data requirements are also used in your application design. And in your application design, the first step is your functional analysis. After a functional analysis, you do application program design. Then you do transaction implementation. In your functional analysis, you can use requirement collection and analysis that you did for your database design. In your second phase of application design, you can use your logical schema, that is easy. And in your third phase, that is transaction implementation, you can use your internal schema. Our focus of this chapter is this right-hand side, this green rectangle. Right, the left-hand side, application design, it's not a focus of our chapter. I just explain these steps, that these are also linked with each other. Okay, so let's begin with our conceptual design. Conceptual design, our first phase is conceptual modeling. And what are the steps of our conceptual design or conceptual modeling? The first step is, there are 5 steps. Since this is phase 1, so I numbered them 1.1, 1.2, 1.3, 1.4, and 1.5. So it means the first step in phase 1, second step in phase 1, third step in phase 1, fourth step in phase 1, and fifth step in phase 1. So what is step 1? We identify entities. Step 2, we identify relationship between entities. Then in third step, we identify the, one moment. In third step, we mention the relationship with the entities. 4 steps, we identify the attributes and we identify the domains of attributes. These concepts are coming in next slides. Then in fifth step, we determine different keys, including candidate key, primary key, and alternate keys. So let's discuss them one by one, each step. To understand these steps, let's first consider a scenario, a case, an example, company, so that it is easier for us to see the examples. All of you, please read this slide with me so that we can all be on the same page. Okay, please all read with me. We need to create a database schema. Yani we need to implement a database based on the following requirements. And these requirements are for a name, for a company whose name is company. First requirement is the company is organized into departments. Like in our university, we have different departments. Each department has a name, has a number, and has an employee who manages the department. Yani in our university example, it can be dean. We keep the track of start date of the department manager, yani when the dean started his job at the department. So we keep the starting date, we store it. The department may have several locations because department is bigger. So it has one building here in Hayya Safa, second building in Hayya Jamia, third office at some other locations, etc. In each department, it controls several projects. For example, in our college, one project can be IS department, second project can be IT department. These are further actually departments, and inside the departments, there can be several projects. These are, since it's a generic company, so you can call it, like in our university, they are running several different degree programs. They can be considered as our projects anyway. Each project has a name, unique name, and project number, and it is located at a single location. Okay, so we need to store the location of the project. Second, of course, in the company, employees are working. So for each employee, we should store our social security number, address of the employee, his salary, sex, and birth date. Similarly, for each department, we need to store the department name, sex, dependent. Sorry, this is not department, this is dependent. Each employee has its dependent. Yani, the employee has his kids, his family members, etc., etc. So we need to store who are the dependents. For each dependent, we store their name, we store their sex, birth date, and what is the relationship to the employee of each dependent. For example, the dependent 1 can be the son, dependent 2 is the wife, dependent 3 is the daughter, etc. Okay, so now some concepts of our ER model, also called ER diagram. We have three major things. Some other small things are also there. The first major thing is our entity. I translated it from Google. Let me know if it is correct or not. Entity in Arabic, you can call it kayan, kanuna, wujud. Attributes, you can call it sifa. And the third one is relationships. Okay, is this good translation, guys? Entities and attributes. Attributes or the properties. Do you have a better word? Do you think we have some other translation, because there were many different words for attributes or the properties, or sifat? I think this can be another translation of attributes. Am I right? Okay, Ahmad says this is good. So in entities, what are the entities? Entities are the specific objects or things in our mini world for which we need to store data into our database. For example, employee is an entity, department is an entity, computer is an entity, car is an entity. These are examples. Attributes, they are basically properties of an entity. They can also be the properties of relationship. The examples are coming next, don't worry for this one. For entities, the attributes can be, for example, our entity is employee. What can be the properties? What can be the attributes of employee? These are all the details that we need to store for employee. What do we need to store for employee? We need to store his name, his social security number. Here for you it is Hawaii number, for me it is Ikama number, address, sex, birth date. These are the items that we need to store for employee. For each of these attributes, we will have the values. For example, name, the value can be John Smith. The social security number, the value will be something, 1, 2, 3, 4, 5, 6. Then the address, some number, Hayy al Jamia, Jeddah, KSA. Sex, male, birth date, 9th January 1955. What can be the different type of attributes? It can have three different types. First, simple or composite. We will study it as simple or composite. Second, single valued or multi-valued. Third one, derived attributes. Okay, so let's see first of all simple attribute. If each entity has a single value or single value of the attribute, it is called simple attribute. For example, student ID. If I say student ID, you have one ID. If I call it your Hawaii number, you have one Hawaii number. Okay. These attributes are called simple. But there are others which are called composite. For example, when we talk about your name, so your name has several different parts. First part, first name, middle name, last name. So if an attribute, it has more than one components, it is called composite. Similarly, your address has your apartment name, house name, street name, zip code, city name, country name. All these things together make your address. So your address is an attribute, but this attribute has several different components. That's why we call it murakkab. Our next property of attributes is that it can be a single valued and it can have a multi-valued. Let's say for single valued, if it has only one possible value, that is single valued, and multi-valued where you have more than one values. For example, many students, if you talk about your phone number can be one value. For many people, they have more than one phone numbers. They have more than one mobile numbers. Sometimes they have one mobile, one landline. So it can have more than one values. Phone number can have two values, for example. Similarly, some people they have one car, some people they have maybe more than one car. So if I ask them their car number, so they will say we have two cars, I have two cars, or etc etc. Some families have more, so they will give me two different car numbers. If there are more than one values, it is called multi-valued. Otherwise it is called single valued. Okay, another good, very interesting concept of the attribute is derived attribute. What does this mean? Derived attribute is an attribute that is calculated from some other values. For example, in your grades, you get grades of your individual subjects. From these individual grades, we calculate your GPA. Okay, so GPA is calculated from other attributes. Then GPA is called derived attribute. Okay, one interesting concept, very interesting, very important. We never store derived attribute in our database. We are calculating it on the runtime. When I say, maybe it means take from. Yes, something like that, because your GPA is derived from your grades in individual courses. So something that you will be calculating from other values, we never store this into our database because it is always changing. In first semester your GPA is different. In second semester your GPA is calculated again. Your third semester GPA is calculated again. So that is why we do not store derived attributes, because those are changing. We do not store it into our database. Rather, when we have to show it, we calculate it and then we show it. Okay. We do not store derived attributes into databases. We calculate it at runtime. Okay. Here is one example of composite attribute. Yeah, this is composite attribute, and this is the example of composite attribute. Your address is made up of your street address, city, state, zip code. Your street address is made by street number, street name, and apartment number. Okay. Then is our concept of key attribute. When we are storing your data, for example, we are storing data for the students. We are storing their IDs, we are storing their names, we are storing their address, etc., etc. Out of these attributes, some of the attributes, they have unique values. For example, your student ID. Student ID of one student does not match with any other student. It is unique. It is not repeated with other students. Second example, your mobile number. If you have a mobile number, it is unique in the world. No one else in the whole world has the same mobile number, including, of course, the country code. Then talking about your national ID, always it is unique. You have a national ID, no one else has the same national ID. So these attributes which have unique values, they are called key attributes, or also simply call them key. So this is a key, or this is called a key attribute. Okay. Also your vehicle identification number, yani your car number, which is on the back of the car, also in the front of the car. These are also unique, at least in your country. And the engine number or chassis number, it is also unique. Okay, some more concepts, very important. Inshallah, you will understand them easily. The first thing is super key. Very simple. All the keys are called super keys. So you can say we call it super key or we call it simply key attribute. It's the same thing. Then next concept is candidate key. If, for example, if I show you an example of, let me type it here for you an example. I want to store student data. Okay. For student data, I want to store their ID, comma. Then I want to store their name, comma. I want to store their city, comma. I want to store their degree program, yani IS or IT, or then I want to store their courses. Yes, one thing more I should store. So this is their ID, is their student ID, and then I want to store their national ID. Okay, these are the items that I want to store for each student. Out of these items, out of these attributes are student ID, national ID, name, city, your degree, and your courses that you have registered or you have taken. Out of these attributes, what are the attributes which have unique values? Time for you guys to reply or speak. Out of these attributes, what attributes have unique values? Name can be repeated. Maybe like your name is Ahmad Ali Ahmad Al Ghamadi, maybe somebody else also has the same name. So name is not unique. ID is unique, of course. Student ID is unique. National ID is also unique. Courses can be repeated. For us, courses can be repeated. You have taken 2 courses, maybe somebody else also has taken the same courses. Yes. So student ID and national ID, they are unique. Phone number I have not stored here. If phone number is there, then it will also be unique. Email, if I store here, you see, I haven't taken, I'm not storing their phone number, I'm not storing their email. If I store them, they will be unique. Okay, let's include it here. Mobile, email, okay, city, country, username. Ibrahim, you are right. Username should be unique, but we are not storing here username. You see, in our example, the attributes are here. So out of these attributes, what are unique? MashaAllah, tabarakallah, at least you understand that the attributes, what attributes are unique. Talal, city name is not unique. For you, city is Jeddah. For another student, it can also be Jeddah. For third student, it can also be Jeddah. So city may not be unique for all students. Unique means its value is different. Home address can also be, yeah, complete home address will be unique, but maybe 2 students, that's why I didn't say home address. I said city, so it can be repeated for many students. Country can be repeated, okay, degree can be repeated, etc. Okay, guys, mashallah, mashallah, excellent. So you got the idea of super keys. Now, student ID and national ID, I should highlight it with blue to make you understand that these are super keys. Okay, Super key is country, address, mobile, email. Okay, let me also make them blue. Super keys, these are super keys, number 1, number 2, number 3, number 4. Okay. Let's see some more. I explain this to you candidate key in a while. Before I explain this candidate key to you, I should explain, where is that? Okay. Okay. I need to take another example. This is car ID. That is car ID, and in car ID we store the state. Car ID is our state, comma, number, state, comma, number. Okay, let me erase these two, make it blue. Make it smaller. And city, company. Okay, something like that. Okay, guys, now have a look at it. This is our key or super key. This is also our key or super key. And our car ID, you know that it is also unique. If we have the state name and its number, it will always be unique. It will not be repeated, because in one state, the name of the states are unique, and in one state, the numbers of the car number, which is written in the back of the car number plate, it's unique. Your name, it can be repeated. Maybe 2, 3, 4 students have the same name. City can be repeated, country can be repeated, degree can be repeated, courses can be repeated. Okay, see here, state ID is simple attribute. It's not composite. National ID is simple. Car ID is composite. It is murakkab. So it means it has more than one attributes inside it. Out of these 3 super keys, we have to sum for our further actions. We will choose the one which has minimum number of attributes. Student ID, 1 attribute. National ID, 1 attribute. Car ID, 2 attributes. So we will select out of these 3 those which have minimum number of attributes. Student ID, 1 attribute. National ID, 1 attribute. Car ID, 2 attributes. So we will not select 2. Is there lesser than 2? Yes. 1, here is 1, here is 1. So we can select both one of these 2 for our further. Okay. So those keys which have minimum number of attributes, those are called candidates keys. The keys, this is a key, car ID is a key, national ID is a key, student ID is a key. Both of these are keys because they are unique. They have unique values. So those are keys or super keys. Out of these super keys, we select some of them which have minimum number of attributes. How many attributes are there in student ID? 1. How many attributes in national ID? It is 1 attribute, simple attribute. Car ID is composite, so it can have 2, sometimes it can have 3, etc., etc. So we are selecting those attributes which have minimum number of attributes. Those attributes are called our candidate keys. Okay, so we select national ID and student ID as candidate keys. Look at this picture. The whole outer box, outer oval, outer circle, it represents our super keys. Yani there can be many super keys. Out of these super keys, we select some of them which have minimum number of attributes. minimum number of attributes. I should highlight it green. Let me make it green so that the color is the same. Which green color? Maybe this one. Well, a little bit different. This green color highlight and this green color, which have minimum number of attributes. Those are called candidate keys. Candidate, something that can, okay. So out of the candidate keys, we had 2 candidate keys. How many super keys? 3. Out of these super keys, we are selecting murasha, yani those which have minimum number of attributes. Here we have one attribute, we have one attribute. Okay. Out of these 3 super keys, 2 are candidate keys. These 2 are candidate keys. Out of the candidate keys, we select one, anyone as primary key. Primary key means main key, major key. We will select one of them, only one. Primary key is always only one. So any one of these we will select as primary key. You can select national ID or you can select student ID. This is your choice. This is your choice. Okay, let's say I select student ID as primary key. The remaining keys, remaining candidate keys will be called alternate keys. Remaining keys are called alternate keys. Let me do this for you. Wait here. I write it for you here. So our super keys in this example are 3. Oh, come on. Our super keys are 3. Okay, in this example. Then I select candidate keys. Candidate keys are the keys which have minimum number of attributes. These 2 keys, they have 1 attribute each. So we call them that these are candidate keys. Okay. Then out of my candidate keys, I have to select one of them as primary key, because primary key is always 1. Primary key. Which key should I select for primary? Any candidate key. Any candidate key you can select as primary key. Uh-oh. It is not working, so I work it like that. Okay, primary key. Which one should I select for primary? Anyone you like. Let's say I say student ID is my primary key. The other candidate keys. What are the other candidate keys? Those we are left with national ID. The remaining candidate keys are called your alternate key, which is here national ID. So candidate keys are, alternate keys are basically your candidate keys minus your primary key. All keys other than your primary key, all candidate keys other than your primary keys are called your alternate keys. Okay. Once again, I'm repeating it for you. First of all, we need to find super keys or keys. The attributes that have unique values. Unique values. Those are your, give me a second guys, I need to do something. Control C. Okay. First of all, I need to find super keys. Super keys are those which have unique values. Out from this example, what are the attributes that have unique values? Student ID, they are always unique, never repeated. National ID, always unique. Your car ID, yani car number, including the state, including your car number. These are always unique. So we have 3 unique keys. These keys are called super keys. These are 3 super keys. Then from these, we select some of these which have minimum number of attributes. Okay. See this picture? In this picture, this blue oval, blue circle represents your super keys. So we can have many super keys. Here we had 3. From these super keys, we select some of them which have minimum number of attributes. Our student ID is 1 attribute, national ID is also 1 attribute. So we have 2 keys which are our murasha, yani which are our candidate keys, because they have minimum number of attributes. Out of these 2, select anyone, whichever you like. Let's say you select student ID. You selected 1 student ID as primary key. One of them is primary key. All the remaining are alternate keys. So primary key is any candidate key. And the remaining candidate keys, yani you subtract primary key from them, the remaining keys are called your alternate keys. Is it clear to you guys? Is it okay now? Okay, Alhamdulillah. Don't worry, we are going to do inshallah a lot of examples. This picture also tells you the same thing, super keys. We select some of them as candidate. Then out of those candidate, 1 is as primary key, the remaining will be your alternate keys. Okay, it's here, primary key, alternate key. Next is, we are now starting towards our ER representation. In ER diagram or ER model, each entity is represented by a rectangular box. And then rectangular box may be connected with other rectangular boxes. Each, for example, let's look at this picture. Our entity is car, and car has several attributes. For example, the model of the car, make of the car, color of the car, year, registration of the car, vehicle ID. These are the attributes, and these are represented by ovals. Okay, you see here some ovals. For example, this one, it is multi-oval. Yani this value, this attribute has more than 1 values. Usually here in Saudi Arabia, I see cars only with 1 color. If it is black, it is black. It is white, okay, white, all white. But in other parts of the world, we have some cars which have more than 1 colors. Maybe red and blue, maybe white and blue, etc. Green and yellow. So if we have more than 1 colors, more than 1 values of an attribute, that is called multi-valued attribute. So a multi-oval represents a multi-valued attribute. So it means more than 1 values here. Your mobile number, it is also multi-valued. You may have 2 mobiles, 2 numbers, so it is multi-valued. Then you see here some attributes are underlined. Registration number, vehicle ID. Vehicle ID is your engine ID, chassis number, which is written on your engine. It is also written on your left side door. If you see, there is a sticker, and usually on that sticker, or yeah, usually on the left side of the door or somewhere under the driver's seat or under the footpad, there is a sticker that represents your engine number. This is the vehicle ID. The registration number is the number that is on the back and front of your car. That is your registration number. Since this book comes from US, so they have in their registration number, they have state name and the number. Together, it makes their registration number. So one attribute, registration number, and vehicle ID, they are underlined. Why they are underlined? Because both of them are keys or super keys. What do we mean by key or super key? We mean something which is unique, which is not repeated. Your vehicle ID, any engine number, is never ever repeated in the world. Normally it is never repeated. Somebody may be changing engine number, etc. So that's wrong, false. Registration number is always unique. So both of these are unique. So that's why they are underlined. These are keys. Okay. Once again, summary. An entity is represented by a rectangle. Car is an entity. It is represented by a rectangle. Then all the attributes of that entity are represented by ovals. Model is an attribute. Make, year, vehicle ID, all these are attributes. The attributes which are unique are underlined, and attributes with multiple values, it can be one or it can be more than one. They are represented with multi-oval. To understand this part, which is a part of ER diagram, it is not complete diagram, it is a part of ER diagram. We are going to see to make it complete. To understand this diagram better, let's take some examples. The first example of car number 1. Car number 1, we are storing their values like this. First of all, registration number is stored. In the registration number, we are storing the car number and the state name. Then we are storing vehicle ID. Then we are storing the make of the car, model of the car, year, and color. For first car number 1, the registration number may be something like ABC123, like this is the number on the back or front of the car. This is the state, Texas. Then the vehicle ID. Vehicle ID is the engine number. This is vehicle ID. Then is make, that Ford Mustang is make. Model, convertible. Year, 2004. Color, red and black. For a second car, the values can be ABC123 and the state is New York. The vehicle ID is WP9872. The make is Nissan Maxima. Model is 4-door. Year is 2005 and the color is blue. For a third car, the registration number can be VSY720. State can be Texas. Vehicle ID TD729. Make Chrysler LeBaron. Model 4-door. Year 2002. Color is white and blue. So these are the possible values for a car with these attributes. And for that car, the ER diagram will look like this. Is it clear to you guys? Say yes or no. If no, I can explain this to you again. Okay, so some student says that I should repeat. I was saying in this slide how to make ER diagram. We are starting with making ER diagram. Okay, in ER diagram, what are the 3 major components of ER diagram? If you remember, the 3 major components of ER diagram are: we should have entities, we should find attributes, and we should find the relationships between our entities. Okay, so our first step is find entities and attributes. In this example, I showed you that entity is represented by a rectangle, car is an entity, and car has different attributes: registration number, vehicle ID, model, make, color, year. All the attributes are represented with ovals or circles. Okay, and you see that some of the attributes are underlined. Why those are underlined? Because they are unique, they are super keys. So all super keys are represented by underlined name. Their names are underlined. Second, you see this is multi-oval. It means this attribute can have more than one values. So this is an ER diagram for entity car. To understand it better, I gave you several examples that for car number 1, these can be different values. For car number 2, these can be different values. For car number 3, these can be different values. Our objective is to make ER diagram. This is the ER diagram for entity car. We are going to see more examples, inshallah, in coming slides. So stay with me, inshallah, you will understand it. Okay, once again, we take our example of our company database that I showed you in last slides. So this is just a summary of those 2 slides. We need to create a database for our company. The name of the company is company, and the requirements are that in company database we have departments, we have projects, we have employees, we have dependents. These are our entities. Okay, how do we make ER diagram of our this company database? The very first step is we identified entities. How to identify the entities is simple, very simple. All the nouns are either entities or properties of entities. This slide shows us the description of the company. We read the description, and for description we found what are the nouns. Noun means ism. In Arabic you call it ism. So what are all asma or nouns? We find them. Department is an ism, and each department has a name, ism. Number of employees, who manages the department, the starting date, location. Again, the second ism is project. And you see here some names, they further explain other names. Like department is explained by its name, number of employees, the dean, the manager, the location, the projects it is doing. So these names are called attributes of entities. Okay, so our first step is to identify all the names. Some of the names will be our entities. The other names will be properties of our entities. Okay, when we see this slide here, our company database, we find some names like departments, like projects, like employee, like dependents. These are our entities. The remaining are properties of entities. So coming back to the same slide, our entities are project, department, project, employee, and dependent. These are our entities. How do we represent entities? Entity is represented by a rectangle. How do we represent the properties or attributes of entities? We represent with the help of ovals. Let's see it once again. We had an entity which is our department. So department will be represented by a rectangle. All the attributes of department. What are the attributes? Name, number of employees, uh, number, and an employee. Okay, so it has, department has a name. How should I say it? Has a name, number of department number. Okay, that is basically department number. Employee who manages it, yani manager, name manager. It is called manager. Okay. A department may have several locations. So our entity is department. Department is represented by a rectangle. What are the attributes of department? The attributes are the name. This is the first attribute. Department number, name, department number. The manager is another attribute. Location. A department may have several locations. Yani it has several offices. One office is in Jeddah, one is in Makkah, one is in Medina. So since it have more than one values, we represent it with multi-oval. And manager start date. So it has 5 attributes, 1, 2, 3, 4, 5. My question to you here, these 2 attributes are underlined. Why these 2 attributes are underlined? Name of the department and number of the department, they have unique values. These name and number, they are unique. They cannot be repeated. Department name cannot be repeated. Department number cannot be repeated. So that's why these are unique. Since these are unique, that is why we underline them. Why do we make multi-oval with the location? Because there can be more than one values of the location. Second part, second example. Our second entity is project. First entity is department. Second entity, project. So project is an entity. It is represented by a rectangle. What are the attributes of this entity? Attributes are name, project number, and location. So project name, project number, location, and controlling department. Each project is controlled by a department, by one department. Okay. How will we make an ER diagram? We will represent the entity name with the rectangle and attribute names with ovals. The attributes which are unique are underlined. To understand this picture, we make a table to show different values. For example, the first project name is Ring Road 1. Ring Road 1, Tarif Dairi or Dauri, something like that. The project number is 1. And the location is Makkah. And which department is controlling this project? Let's say IS department is controlling this project. Second value can be the project name is Ring Road 2. Project number is 2. Where is it located? It is located in Makkah. Which department is controlling it? CS. So here you see different values of these attributes. This table is not part of ER diagram. This table is just made to make you understand this ER diagram better. So this is the ER diagram. This table is not part of an ER diagram. It is made only for your understanding. Third, our third example, third entity. What is our third entity? Employee. So let's make an ER diagram of employee. How do we represent our entity? We represent it with the help of a rectangle. Entities are represented by rectangles. These are ovals are their attributes. Employee has a salary, employee has a sex, employee has a social security number, employee works at some department, it has a birth date, employee has an address, supervisor, employee works on a project, employee has a name, and name is made up of first name, middle name, and last name. We get these details from our very first phase. Our very first phase was data collection and analysis. If you remember, the first phase is data collection and analysis. When we were collecting data, we will talk to the employees. Oh, thank you, Ahmad Ali. We will talk to the employees of the company organization. We will ask them, what data items will you like to store? They will tell us that we like to store these data items. From their understanding, we will make ER diagram. We do not make this ER diagram from our own understanding. We ask them what are their data requirements. They tell us these are our data requirements. These are the entities, these are the attributes. So we will identify entities and attributes from their description, from their interviews, from their reports, from their forms. Okay, by after studying their requirements, we will make this ER diagram. This is the ER diagram of employee. Our fourth entity is dependent. So a dependent, uh, each dependent we keep to track their name, sex, birth date, and relationship to employee. Employee is an entity. It is represented by a rectangle. The attributes are name. Name is here. Where is the name? Yeah, dependent name. It's here. Sex is here. Employee and the employee whose dependent is he. The employee. You can call it the main employee for whom this dependent is. Okay, so for example, anyone has a dependent in his family, his wife, his son, his daughter. Sometimes the dependents are also parents. If parents are not earning anything, they are also included into dependents. So we will say the dependent name, maybe here will be the wife name, and here is the name of the employee this dependent belongs to. Then the sex of the dependent, if it is wife, it will be female. If it is son, it will be male. If it is daughter, it will be female, and so on. The birth date of dependent and relationship, son, daughter, wife, etc., etc. Putting these four entities together, we see a picture like that. Department, entity, attributes of the entity, department. Project is an entity. The four attributes of project. Employee is an entity and different attributes of employee. Dependent is an entity and different attributes of dependent. Okay, so far, please ask if you have question. If anything is not clear, I will repeat it for you. Because we are going to stop here today. I think these are enough concepts for one lecture for you. Inshallah, we will start from here, continue from here in our next class. Any questions? Any problem? Okay, Alhamdulillah, that's great. I can, Jazakallah khair, thank you, Abdullah. I can understand that from remote, it's a bit difficult because you do not see me, I do not see you. You only hear my voice and see the slides. So it's a bit not as convenient as the physical classes. So that's why I'm trying to make it very slow. Not very slow actually, to make it good pace, not very fast. Not at, of course, we cannot go at a regular pace, because if we go at regular pace, it might be fast enough for some of the students, and they may not grasp it as we should have it. Anyway, so it seems there are no questions and no problems. Alhamdulillah. Alhamdulillah Rabbil Alameen. This is good that you understand it. Summary, I tell you that today we started learning our ER diagram. ER diagram is basically our conceptual schema. We have started our first phase of database design, which are conceptual design. In conceptual design, we make ERD, ER diagram. How to make ER diagram? We identify entities, we identify attributes, and we identify relationships between them. How do we identify entities? These are all nouns, all ism. So ism can be an entity or the property of an entity. If an ism can exist independently, it is an entity. If an ism or noun cannot exist independently, it will be a property. For example, I say name. So name cannot exist independent. Of course, it is a name of a project. So we must have a project, then we will have a name. Similarly, number of what? Number of project ID. So we must have an entity for which will say that it is a property of, or it is an attribute of. So some names, some nouns which cannot exist independently, those are our attributes. The nouns or ism which can exist independently, those are our entities. So we identify entities, we identify their attributes, then we represent them in this picture like that, where we represent entity with the help of a rectangle and attributes with the help of ovals. Then we underline the attributes which are unique. Those are called super keys. This picture is called our ER diagram. This is the start of ER diagram. This is not complete. This is the start of ER diagram. We did some part of ER diagram today where we identified entities and their attributes. In next, inshallah, lecture, we will learn how to find their relationships, how to represent their relationships, and other things, inshallah.